Fractions and decimals in order of operations. So, first question is, we're going to convert these fractions to decimals. We're going to use long division. That's 2 divided by 5, which means we're dividing 5 into 2. So the 5 goes on the outside. Of course, 5 won't go into 2, so we throw in a decimal and then a 0. Bring the decimal straight up. 5 goes into 24 times, and 4 times 5 is 20. Subtract, we get 0, and we're done. Let's do 1/9. Now it won't go into 1, so we put a decimal to 0, bring the decimal straight up. Now we're going to 10 one time. 1 times 9 is 9. Subtract, we get a 1. Throw in a 0. Bring down 0. 9 goes into 10 one time. Multiply. Subtract. See a pattern developing? Looks like it's going to be 0.111. 111. It never stops. So what that means is that 1/9, the way we're going to write it, is 0.1 with a bar over that 1, because that 1's repeating. You don't put it over 11 or 111, because after the decimal, it's just a bunch of 1s repeating. So put it over the first digit that repeats. Now 3/7 is going to take a little bit more space, and so let's do that one. 7 into 3 won't go. Put in a decimal, bring it straight up, throw in a 0, divide. 7 goes 34 times, subtract, throw in a 0, bring it down. 7 goes in 22 times, multiply, subtract, throw in a 0, bring it down. 7 goes into 68 times. I'm going to do this a little bit quickly, save some time. As you can tell, nothing nice is resulting yet. Not sure why that line is there. You see something going on here? It's taking us a long time. Seven goes into 30. I'll have to do a few more digits. 7 goes into 20. Now, if you notice something, I'm seeing the same numbers. 4, 2, 8, 5, 7, 1. 4, 2, can you guess what the next one's going to be? 7 goes into 60 8 times. See the pattern? What that means is the 4, 2, 8, 5, 7, 1, 4 are all repeating. That's our answer. Yes, it is true. You're going to have more than one digit repeating. 4, 2, 8, 5, 7, 1, 4. That's how you would write it. Did you catch the mistake in the previous example? Notice I had the line drawn over 4, 2, 8, 5, 7, 1 and the 4. But I don't want to put it over the 4 because that's the first digit that starts to repeat. So the line should have been only over the 4, 2, 8, 5, 7, 1. So therefore 3 over 7, represented as a repeated decimal, will be as such. Because the 4, 2, 8, 5, 7, 1 will keep on repeating over and over again. So I only need it over these digits. 4, 2, 8, 5, 7, 1. Did you catch it? Let's do one more. Let's do 1 divided by 6. Won't go evenly. Throw in a decimal. 0, decimal. 6 goes into 10 one time. 1 times 6 is 6. Subtract. Throw in a 0. Bring it down. 6 goes in 46 times. Subtract. Throw in another 0. Bring it down. Oh, see a pattern developing? I see it. What that means is that 6 is repeating. That's the only one that gets the bar. So be aware of those. That can happen. Let's go back to the 1/9. 1/9 is 0.1 repeating. Guess what 2/9 is? 0.2 repeating. Guess what 3/9 is? It's the same as 1/3. 1/3 is the same as 3, or 3 repeating. Keep that in mind. Guess what 4 nines is? 0.4. Guess what 5 nines is? 0.5. So little things like that can save you a lot of time, especially for other questions like this. 3/5, 0.66. Which one is bigger? Well, what you might want to do is convert 3/5 to a decimal, which is what we're going to do. If you know anything about decimals and fractions and how they relate to 100, this can be a lot quicker than what it is. You can always do like we did up here, but if you think about it, 1/5 of a dollar is 20 cents. So 3/5 would be 60 cents. So 3/5 is the same as 0.60. And 0.60 is less than 0.66. Now here's what I mean about things like this, or using things that you already know. 2 nines is the same as 0.22 ... It never stops. 1/4 is the same as 0.25, and it stops. As far as the 5 goes, it stops. That 2 and that 5 is all you have to look at. 2 is less than 5, so you're done. Let's do one more, one that a lot of people miss. Let's compare pi to 3.14. A lot of people think that these are equal. They're not. Pi is greater. Pi is actually, if you keep on going, 3.1592 ... 3.14 looks like that. If you want to keep on going with this number, there's a 0 on the end. So that one is bigger than that 0. Better than. Now let's do some order of operation problems. Let's do a quick review of order of operations. PEMDAS. P is parentheses, brackets, braces, absolute value bars. E is exponents. M and the D are multiply and divide, whichever comes first left to right. A and the S are add and subtract, whichever comes first from left to right. So in this problem, what you want to do is, you want to do the exponent first. A lot of people miss this exponent. If you do this, if you write it in expanded form, you probably won't miss it then. So we have 0.2 times 0.2, it's the same as 2 times 2 is 4, but there's 2 numbers after the decimal, so we need 2 numbers after the decimal, so you throw in a 0. 3 times 4 is 12, we need 1 number after the decimal, so it goes there. And then we think 0.04 minus 1.2 is kind of like this. If you take 4 cents away from $1.20, that means you owe $1.16. 4.9 times 100. Let's write down our 2 zeros. 1 times 49 is 49. There's 1 digit after the decimal. We need 1 digit there. That's 490. Minus 8.7 times 10. Throw it down to 0. 1 times 87 is 87. 1 number after the digit. 1 number after the digit. 490 minus 87 is 403. Let's do this one. By the order of operations, we do parentheses first. Watch this. I like using money. $11.20 minus $8.90. What's the difference? Most people could think about it and see 2.30 or 2.3 is that we really need to look at. I'm going to mark up that 0 because it really is just 2.3 in this problem. I was thinking money when I was doing this. Now if you want to, you can always come to the side and do it. Nothing wrong with that. We'll borrow from that 1, mix that a 0, mix that 2 with 12. We get 3 when we subtract, and 10 minus 8 is 2. Now we multiply. 8 times 3 is 24, carry the 2. 8 times 2 is 16, plus 2 more is 18. We have 2 numbers after the decimal, so we need 2. So there's where the decimal goes. And that's just a few questions about order of operations. Area of a triangle. Formula for the area of a triangle is 1/2 base times height, or A equals 1/2 BH, where B stands for base and H stands for height. Give you a quick example of where this formula comes from. Most people know the area of a rectangle is length times width. Now, this lopsided rectangle is called a parallelogram. It works the same way, except we really don't call it length and width, we call it base and then height. Now, if we were to cut this in half, this right here would be a triangle, with base B and a height H. So this half of a parallelogram is a triangle. So half the area of a parallelogram is half B times H. Got that? That's where this comes from. Let's do some examples. Let's find the area. Let's just do, we'll do a couple of triangles. Let's do a right triangle. Let's say this is 4 centimeters and this is 10 centimeters. So the formula we're going to use is 1/2 base times height. Notice how I write these out. I always use parentheses to represent substitution. The base is 10 centimeters and the height is 4 centimeters. So what we're going to do is take half of 10. You can think of it like that. Half of 10 is 5 centimeters. Then times that answer by 4 centimeters, and we get 20 square centimeters. Centimeters times centimeters is centimeters squared. Now watch this triangle. Let's call this base 20 feet. Now the height is going to come outside. It's like if you were trying to move some kind of crane into a building. This wouldn't be your height. The height would be, how high does the door have to be for the top of it to get in? From the top of the crane to the floor. So the height is always straight up and down. It's always vertical. So let's call it 8 feet. So once again, let's use A equals 1/2 base times height, where the base is 20 feet and the height is 8 feet. Take half of 20, which is 10 feet, multiply that by 8 feet, and we get 80 square feet. And that's all we're doing.